Hello, everyone. My name is Ann Ballantyne, and I am a CSPC Program Committee member. On behalf of CSPC, a warm welcome to everyone. We're about to participate in a very exciting conference session with the code 458 titled Curiosity and Mission-Driven Research Collaborations, a precursor discussion to the upcoming International Conference on Research Infrastructures, ICRI 2021, organized by the Canada Foundation for Innovation and the National Research Council of Canada. Before we begin, I'd like to provide you with a couple of housekeeping notes. Please turn off your videos and microphones. Please also note that the session will be recorded. Please don't forget to tweet about your favorite events and panels at the conference using @SciencePolicy and hashtag CSPC 2020. In the chat box, I will be adding the links for a short survey that should only take a minute or two to fill out. You can fill this survey out at any point during this session. I encourage all of you to please fill this survey out to help us make CSPC better in the future, especially as we're navigating this new online medium. Without further ado, I will now pass things over to Dr. Roseann Runte, the President and CEO of the Canada Foundation for Innovation, who is the moderator of this session. Thank you, Dr. Runte.
Thank you so much, Anne, and thank you. You have been a volunteer for the CSP conference for at least 3 years, and I think the conference is a success because of the volunteers and the students that participate in the conference, because they're the next generation. So thank you very much. So much. Today, we're honored to have an extraordinary panel of scientists who have truly fine careers and impressive responsibilities. We've actually reached around the globe to bring international expertise to our table, and have looked closer to home to find academic leaders who have both served on provincial and federal government levels, and who have not only worked with enterprise, but started their own businesses. Dr. Gail Murphy is Vice President Research and Innovation at the University of British Columbia, Professor of Political Science, and co-founder and director of Tasktop Technologies Incorporated, a company that improves the productivity of knowledge workers and deals with the evolution of large software systems and performs empirical studies to understand how developers work. She is the recipient of numerous awards as a distinguished scientist, professor, innovator, and has so many papers rated as influential that she is truly in a class of her own. Dr. Geneviève Tanguay is a bioscientist, and she's Vice President of Emerging Technologies at the National Research Council, responsible for advanced electronics, photonics, nanotechnology, disruptive technologies, meteorology, astronomy, and astrophysics. One might ask, what more could one possibly ask her to do? She has served as president of ACFAS, which has 7,000 members. She's been sous-ministre adjointe à la recherche et l'innovation pour la province du Québec, and vice-rectrice de la recherche, création et innovation à l'Université de Montréal. Dr. Fred Wrona is a research professor at the University of Victoria and director of Aquatic Ecosystems Impacts Research Branch, Division of National Water Institute, Environment Canada. He's a former land scientist at the Alberta Environmental Monitoring, Evaluation and Reporting Agency. He's been senior advisor to Environment Canada, working on climate change and oil sands monitoring. Chief scientist and assistant deputy minister at Alberta's Ministry of the Environment and Parks. He has led the Canadian delegation on Arctic monitoring and served as chief Canadian delegate to UNESCO's IHP, which is the International Hydrology Program. Dr. Volkmar Dietz, a highly distinguished physicist, is director of large facilities and basic research in Germany. Chair of the Foundation Council at the Federal Ministry of Education and Research. He is tasked with supervising DESI, the Deutsches Elektronensynchroton. He has served on the supervisory board for the Max Planck Institute for Plasma Physics and been chair of the Council of the Facility for Antiproton and Ion Research, which is the FAIR Council in Europe. He has previously led a division on sustainability, climate, and energy. His experience thus crosses disciplines and the continent. And today we welcome him from the other side of the ocean. Our panelists today are pondering important issues pertaining to research infrastructure. They're doing this in a bit of a lead up to a conference that will be held in June from Ottawa virtually, organized by the European Council and the Canada Foundation for Innovation in partnership with the NRC, SHRC, NSERC, and CIHR. The conference will talk about governance, financing, and current issues facing research infrastructure around the world. And around the world, we hear much said about the merits of collaboration across institutions and borders, across disciplines, and across cultures. We hear much about the merits of open science and the benefits of sharing research infrastructure, both large and small. And yet, all of these concepts are very hard to achieve. And as we work to this end, how will we measure the impact on society and know our ultimate success? We're going to hear first from Gail Murphy with a university perspective, then from Geneviève Tanguay from the point of view of national facilities. She will be followed by Fred Wrona, who will bring up the provincial and federal aspects together, along with the university point of view. And finally, Volkmar Dietz will share with us the view of our German and European colleagues, explaining how they coordinate their large facilities and share across borders. I turn it now to Gail. Thank you.
Thank you so much, Roseann, and thank you for the invitation to be on this panel. UBC is the second largest research university in the country, and I am grateful and would like to acknowledge the fact that I'm speaking to you from the UBC campus today, which is on the traditional, ancestral, and unceded territories of the Musqueam people. In my remarks, I'd like to try to provide some of that perspective on challenges that we face from a university perspective in large-scale projects and in trying to really further new kinds of technologies in particular. Let me start also by saying that we are grateful to the Canadian government, to CFI, and in BC, to the BC KDF Fund for really helping to fund much of the infrastructure that exists on our campus. Over the last 5 years, we've received about $300 million in funding that helps our researchers have state-of-the-art laboratories. And I thought I would start by giving you a bit of a sense of some of what that equipment has funded and supported. I'm only going to give you two particular disciplines. The range of disciplines that are supported is quite large with different kinds of infrastructure. One example is infrastructure that went into Professor Carl Hansen's lab when he was still full-time at UBC for his work on antibody discovery. Carl really used a lot of that equipment to help incubate a company called Abcelera. And on November 10th, they were able to announce that working with Eli Lilly, they have emergency use authorization for one of their neutralizing antibodies for COVID-19 patients, both in adults and some pediatric cases. So I think that's a wonderful example of where early investment in curiosity-based research has led all the way to something that we are now relying on today for the pandemic that we're in. And as another example, UBC also has the Stuart Blesson Quantum Matter Institute, where researchers have received funding to support building unique research infrastructure to design novel quantum materials. These novel quantum materials can really drive the new kinds of computing that we do, improve batteries, and various other kinds of uses. And this is a nice example in the sense it's now being shared with other quantum researchers across the country and through collaborations with both the Max Planck and with the University of Tokyo. So the ability to bring research funding in for infrastructure, build what is unique, and then be able to share it so that other researchers can also take advantage of it is a really important part of this topic. Now, the kinds of infrastructure that are used by our researchers also exist in larger facilities. UBC is also the location of TRIUMPH, Canada's particle accelerator. And this larger scale kind of infrastructure really requires much longer range planning than maybe even exists within the environs of one or a group of investigators on the university. And it involves the participation of multiple institutions across the country and research labs and scientists from around the world. So we can also in Canada be an attractor when we have big research facilities and bringing in great talent and being able to work with wonderful scientists around the world. In both of those cases, whether that infrastructure is in a environment of a PI's lab or it exists in a larger facility like TRIUMPH, there's some common problems. And one common problem I'd like to highlight is the issue of operations and maintenance and how we actually take care of that equipment over the long haul. We always face struggles within UBC about if we have a facility, how do we make it available to others? Do we figure out some way to cover all the fees for running it and maintaining it? Do we charge user fees to other researchers? How do we figure out how to make the right balance happen there? And sometimes what happens in our country is that you end up asking for new equipment to get new operations and maintenance funding, even if you have older equipment that could still potentially be maintained. We're a campus that really cares deeply about sustainability, so we're trying to look at this problem also from the viewpoint of sustainability. And on the global scale, we're facing lots of questions about how can we as a country, I think, be a good global citizen in large-scale research infrastructure in other countries? How do we partner on big telescopes and other accelerators and big physics installations as others? And how do we make sure that we do that in a way that we're making our own facilities available and also ensuring that we're a good participant in other open science initiatives around the globe? So I hope I've given you a little bit of a sense of some of the things that we're thinking about. Certainly the discoveries that are being made both on the campus and in facilities like TRIUMPH, they're changing our world every day in positive ways, like the antibody example that I outlined at the beginning. So I really look forward to the discussions, and I look forward to how we can actually provide the research infrastructure that's needed to be good global citizens in the world as Canadians, but to also participate openly in a global science community. So thank you.
Thank you very much. Geneviève?
Good morning, and thank you for inviting me to participate in this very topical panel. Innovation is accelerated with appropriate collaboration, which can be reinforced through research infrastructure, for example, cutting-edge scientific equipment or effective data sharing environments. As Canada's largest federal research and development organization, NRC advances knowledge through science, the support of business innovation, and technical solutions for pressing public policy challenges. We are a mission-oriented research organization, and in such, we're complementary to what's being done in the university environment, in the business environment, and also in the government environment, because we fulfill a different role there as well. And to fulfill our mission, it's critical that we have access to the best and the brightest science, technology, engineering, and mathematics talent, and to the state-of-the-art research infrastructure. So NRC is both a funder and an operator of a number of research infrastructure. We manage and operate a wide range of research infrastructure from local research labs, a nanotube production facility, for example, to very large facilities such as wave tanks, wind tunnels, the Canadian Photonic Fabrication Center, and to the very big science facilities, and Gail mentioned them, the astronomical observatories for which we have the mandate to operate in the name of the Canadian community. And we are a steward to TRIUMPH, so in such a role, we actually manage the funding agreement between TRIUMPH and the Canadian government. And Canada's innovation ecosystem can be strengthened by pulling together the complementary expertise and the facilities. It's through collaboration, co-planning, co-delivery, The performers of science, technology, and innovation can better leverage the expertise through sharing the equipment, the data, the samples, train new talent, transfer the knowledge and build capacity where none exist, and efficiently move the results of science and technology along the innovation chain. Facilities may be aimed at fundamental discoveries or mission-driven to address the specific requirements of their users. They can have world-class capabilities that are globally competitive and attracting users and funders from other countries. And this is something that Gail said before me. And therefore, it helps us to have a significant scientific, social, and economic impact. NRC co-invests and partially owns or operates some large facilities using a variety of business models with other governmental departments, with academic institutions, with industry, and with the not-for-profit sector. A sound governance for these facilities is crucial to their optimal performance. And that's something that you have to think before you build, when you're building, and when you're decommissioning. Facilities must be used as platforms for collaboration, avoiding duplication of large-scale investment made by other agencies, industry, or academia. In particular for Canada, we're a big country geographically, but in terms of number of people, we're not such a big country. So we have to make very specific choices, be strategic, and work together. The thing is, we always think about new infrastructure and the promise they represent for science and innovation. But as Gail mentioned, we must think about the maintenance costs. And this is always a challenge. It's also a challenge for the federal government. I would add on top of these costs, the cost of building and commissioning correctly, and also the other important and hidden cost, the decommissioning of some of those infrastructure is also something that must be taken into account. We have many examples of how we collaborate with academia and with industry to foster innovation through what we work. In particular, I could take the telescope example where we use the knowledge that is coming from industry. We get them to even develop new knowledge because those new tools are actually able to do what's not existent right now at a size that is incomparable to what we have right now. So it's important that we work together towards the building of them and then towards the safe operation of these facilities. And it brings us also towards the incredible chance that it gives us to do some international diplomacy, because when you're working with other countries as a partner, and that's something that Gail said also earlier, well, you're building links for the benefit of science and innovation. And it's very important that you respect the cultures of others, that you respect the way that others may be thinking about such an equipment. And it brings you into other spheres that are very interesting, that are peripheral to the pure science and innovation that we're working on, but that's actually very stimulating. So again, I think Fred is going to talk to you about an interesting project that the federal government has launched and in which NRC is very much involved, that will create more collaboration. And collaboration can be done on small, medium, or those big science type of activities. So I'm looking forward to hear what our colleagues have to say and to engage into the discussion thereafter.
Thank you, Geneviève. And on to Fred. You've gotten a real precursor of your announcement.
I certainly have. And again, I want to thank everybody for inviting me to this very, very topical discussion that we're having this morning. And of course, there's been other sessions throughout this conference that have touched base on some of the similar type of arenas of work and issues that we're going to be talking about here, but also in the whole broader context of the role of infrastructure in actually advancing not only the science that we need to do, but actually the role of infrastructure in terms of enabling the types of work that we need to basically implement and conduct at various levels of government organizations, but also in how we interface with the university and private sector communities to achieve these outcomes. I think there's no one that would disagree that science in general, and I mean science in the broadest sense. I think one of the things that I want to emphasize is we're not just talking about physical sciences, we're talking about the humanities, social, medical sciences. I think one of the major areas that we need to have in terms of how we think about our infrastructure and how we move forward is actually recognizing that many of the challenges that we face both regionally, nationally, and internationally is increasingly requiring both trans and interdisciplinary approaches to basically tackle the problem. This in a way, I mean, it might not be new to some people, but if you take a look at the way that many organizations, I think, historically developed, whether it be government research facilities over time, and that could be at a provincial scale or a federal scale, or you look at how universities were basically established, they were very, very, I would say, classical in its approach, where it was discipline-based. You have departments of biological sciences, you have departments of psychology, you have fisheries and oceans research facilities, you have NRC research facilities, and so on. But in fact, really, many of the issues that we need to deal with, as I've mentioned, at a variety of scales, from a technological point of view, from an environmental, socioeconomic point of view, the advancing our scientific discovery and our ability to deal with these types of areas requires us to have this more dispersed, integrated, multi and transdisciplinary approach. And the facilities that we have and the infrastructure that we need to attract that kind of thinking and that kind of interdisciplinary and transdisciplinary approach are not necessarily the way that we've constructed things in the past. And so one of the things that I think is exciting to talk about a bit that I want to raise is that through the Public Services and Procurement Canada program and department, basically there's a new launch of an initiative under Labs Canada that is really trying to work with all federal departments, trying to bring in and have dialogue with university communities, bring in dialogue with private sector and other groups of how do we actually position our new infrastructure in such a way that we are able to meet both current and future challenges, recognizing that we have this multi and transdisciplinary theme that we certainly want to reinforce, and also very importantly to raise now that we have multiple ways of thinking about our science and delivery, particularly if you think about the recognition of Indigenous knowledge and Indigenous information and how that is actually being utilized to work with the wide range of scientific disciplines that we have in this country to collectively deliver on a priority area that is the facility is enabling to do that, but also is culturally and ethically sensitive to the facts of how we actually operate within these multiple domains. One of the things that I wanted to perhaps mention is that, and I think that you said this, Roseann, yourself, that early on, the way that we have to approach these areas is infrastructure is an important enabler, and we certainly need to think about creatively how we are going to break the traditional silos down to bring the right expertise together, both nationally and attract international expertise to help us out. We certainly need to think about how we're going to design our facilities of the future. I think adaptability is going to be very critical. Flexibility in terms of how the facilities operate. But I think what I do want to touch upon, and maybe we'll get into the conversation later, is governance, is how we actually design and implement the science programs that we need to deal with. And so even though we might have fantastic facilities, I think it's already been raised by Gail and others that we need operating and other long-term vision in terms of how we actually not only maintain the infrastructure, but also maintain and operate the science programs that we run through them. This is particularly important from a university point of view, whose mandate also is training of highly qualified personnel to attract the graduate students, undergrads, the teaching component, and also to basically produce the next generation of scientists that we need to have. You actually need programs that are in place that have some resilience to build that capacity up and to maintain that type of work. Currently, there's a lot of effort being spent by by many organizations going after various pockets and grants and programs, trying to weave together what we need to do to have sustainability in terms of our programs. So I want to raise the issue that governance along with infrastructure is going to be very important in terms of how we advance our thinking along these lines.
Thank you very much. That's very exciting doors that you have opened to discussion. I can almost hear the questions flowing in. But before we get there, we have the real privilege of crossing the ocean and talking to Volkmar Dietz from Germany. Good morning. Well, it's not morning for you, is it?
No, it's evening, and just the sun goes down and it's getting dark. Yeah, thank you for the invitation, and I have to say it's an honor to me to participate in this panel. And so I hope you can understand me. I have some problems with the internet connection, and I was thrown out several times. So I hope the internet connection will be stable and you can hear me. And okay, let me give some words on the perspective from Germany, and maybe a little bit also perspective of Europe, because yeah, we are part of Europe. Germany funds research infrastructures for mission-driven research. For example, environmental science, we have 7 large vessels for polar research or maritime research, for example. And also, on the other hand, for curiosity-driven research, like synchrotrons, nuclear reactors for neutron research, or telescopes for astronomy. As large research infrastructures are very expensive in most fields, Germany supports research infrastructure in an international environment. First, of course, we are part of Europe. International for us means first Europe. And this, for example, in Europe, we have this ESFRI process. ESFRI is European Strategy Forum on Research Infrastructures. This is a cooperation of all the European partners being interested in large infrastructures. ESFRI conducts a landscape analysis and regularly produces a landscape brochure of large infrastructure and defines a roadmap for the implementation of new infrastructure. So in Europe, what we have first is we put it on the ESFRI roadmap and then discuss it on the European scale. Another field is international projects like CERN. We participate in CERN. Okay, it's also a European project, but meanwhile, in CERN, there are also at least associated partners from overseas and not only from Europe. And Germany, international facilities also, we have other international facilities also in Germany, located in Germany. For example, ICRI, it's a free electron laser in Hamburg, located in Hamburg, close to DESY. Roseann already mentioned DESY at the beginning. And FAIR also is another example for an international facility located in Germany. It's the facility for antiproton and ion research. And last but not least, we also fund, of course, national facilities, but we also every time with a strong international focus. Of course, let's take, for example, the scientific advisory boards for these facilities are international. To give you an example, take the synchrotron Petra 4 at DESY in Hamburg. This is a national facility, but about 40% it is used by international scientists coming to Hamburg and measure their. So it's not really, if you count the usage, it's not really a national facility. So the message is we are open for international cooperation. We do it first because science needs international cooperation, but also because financing of research infrastructures is in many cases only possible in international cooperation. The cost argument is also an argument not to double efforts. We should look for something like an international division of labor or tasks in science, in fundamental research at large infrastructures. Let me add also a few comments on the title of our panel discussion, Curiosity-Driven Research versus Mission-Oriented Research. Curiosity-driven research and mission-oriented research complement each other. I'm convinced about this. Or let's say, to achieve progress in mission-oriented research, we also need curiosity-driven research as a precursor, let's say, as a precondition. Especially if you take completely new ideas or concepts or research fields, if you want to identify them, you cannot identify them by mission-oriented research. You need this curiosity-driven research. And research infrastructures play a crucial role in combining both aspects as mission-driven and curiosity-driven. As I said, if you want to find completely new fields in science or in technology, you need curiosity-driven research. Just to give you one example, how you find a way to leave the beaten path. No one about 30 years ago had a mission in its mind to develop something like the internet. It was just developed in a surrounding of purely fundamental science, like CERN. It was an idea of CERN at that time. After it was invented at CERN, it developed to this machine which completely changed our daily life and revolutionized economy. So my statement is to identify completely new approaches or revolutionary
We're having a momentary freeze here. The air must be cold over the Atlantic. But I'm sure the ideas are
necessary to
Volkmar, we're having trouble hearing you.
To curiosity structures in fundamental research. Yeah, and later you can focus to resolve. Okay.
So we now have the question of curiosity and mission-driven research, and that sort of ties with the question of sustainability, government funding, and actually also the evaluation of research infrastructure and the product that it has and its impacts on society. I have sat, for example, in Waterloo, Ontario, and the mayor has said, look at Waterloo. This is the result of the research infrastructure that started with the Perimeter Institute. Ah, Volkmar, you have returned.
Okay, sorry for that. I now use a different computer in the next office, and I hope it is better. And
you were in the middle of the curiosity-driven versus mission-driven research.
Okay. So to shorten it a little bit, my statement is that you need curiosity-driven research as a precursor for mission-driven research. And to find really new ideas, it is necessary first to start with curiosity-driven research, and later, if you find something really new, you can focus on mission-driven research and use the inventions you had for mission-driven research. And I gave the example, I don't know whether you could understand me. The well-known example is the invention of the internet at CERN. CERN is completely, purely fundamental research. And 30 years ago, the internet was the ideas for the internet were produced at CERN. And no one had a mission in his mind to find something like the internet. It was just curiosity driven. So give room to fundamental research. That's my message.
Thank you very much. So that brings so around to that question of how do we justify the curiosity-driven research and make it attractive to funders who are actually interested in mission-driven research? And there's the idea, logical and rational and reasonable, that fundamental research is necessary to get applied research to move ahead. And yet, how do you demonstrate that? And I was just starting to say that, in one town in Ontario, Canada, the mayor said, look at this city. This used to be a town of failed agriculture where all the young people went and worked somewhere else. And now it is a research center full of life and excitement. And it's because of the investments that were made by the government through the Canada Foundation for Innovation in the Perimeter Institute that started this whole thing going. So how do you persuade governments to do that first investment? How do you make that first investment sustainable, to start with the theme that's come through everyone? And how do you demonstrate the value of it? And go for it, anybody who wants to bite. Not all at once, of course, but Fred has turned off his mute.
If you like, I may start.
Sure.
So again, from the German perspective. So I am part of the German government. So I'm in the Ministry for Education and Research. So usually there's a well-defined process we have in Germany where the scientists try to convince us. And the ideas for new infrastructures, they are always from science. They are not policy driven or so. And okay, then we start with the roadmap process where new ideas for research infrastructures are evaluated by the German Science Council. And in the end, there's a recommendation which infrastructure we should fund. And the difficulty with this, it's a difficult process because in the end, you have to compare ideas, new ideas for research infrastructures, fundamental physics with, let's say, an idea for a research infrastructure in environmental science or medical research. And that's the difficulty. So in the end, you can do an evaluation by the Science Council, but in the end, it's a political process to decide whether you prefer a new infrastructure in health or in environment or in fundamental research. So, but...
And what happens when the government changes?
Interesting question. Up to now, it never had a consequence on the research infrastructures, at least in Germany. There was, for good luck, a continuity, because we have some, to give you some example, we have some research facilities which took a long time from the beginning, from the first ideas to the realization. Take, for example, the ICRI. It started operation in 2017, and the decision about ICRI was taken by the government in 2003. So there were several governments, but there was absolute continuity in the decision. Yeah, and so we are at least we are in the good situation that it doesn't change with the government. Okay. There's some continuity of the decision. Fred, I hope this will.
Thank you. Fred, I think you were ready to say something.
Thanks, Roseann. Well, I was just going to actually build upon what Volkmar was saying in that one of the things that I think that would be worth a discussion is thinking about how we actually make the worlds of, and we sometimes create our own dichotomies here about fundamental versus mandate driven versus mission driven or whatever. I think one of the challenges, and maybe the way that we need to think about this, is basically what, from a government point of view, and I've worked in the federal government for many years, is what are the problems? What are the issues that need to be solved in terms of knowledge gaps, science gaps, or whatever it might be, and bringing the respective parties to the table. I think one of the things that we often see in some of the successful programs that I've been involved with, both nationally and internationally, is that the design and implementation of the programs involved all parties at the onset. The more that you could be inclusive on the discussion about what you need to actually have in terms of the program design, the infrastructure that might be necessary to support that design, having the government representatives there along with the academic scientists, industry, and other groups collectively thinking about what is needed and who's best served to deal with what piece of it is probably going to be a way that we need to think about this in the future. I think what's held us in the past is we've taken a somewhat siloed approach where we have groups putting a pitch to somebody else regarding what's needed, rather than collectively sitting down and saying, what do we need to actually have as an appropriate governance structure and infrastructure to solve current and future problems. I think the global climate agenda that we're talking about, that all countries face, is a good example that there's no single organization or group that on its own will be able to tackle that direction. And having sort of, I think the conference that's going to be coming up on infrastructure, I think many of the examples that Volkmar has raised, both from a German point of view, but there's many international other examples that we could use as platforms to say this is how some successful large science programs actually were designed and implemented, and maybe that's something for us to consider as we move forward.
I think the idea of problem solving and converging around a problem is really important for the future of the world and our country. But sometimes there are provinces, provincial governments that see the problem as being a regional problem, and they're not really interested in the national or international issue. And they actually may not see the role of social scientists or humanists involved in solving problems that could be health and the environment. And Gail, I don't know if you've had any experience with that and might wish to comment on that role.
Yeah, I think it's a place where, if you think about AI, we kind of came to it late, right? We had a lot of technology develop very quickly, infrastructure that supports, running algorithms on large data sets. And yet we were a little bit maybe later than we should have been to invite those who think about ethics, bias in data to the conversation. And we're trying to take a different approach in the work that many of us across the country are doing on quantum, and saying, how do we get the social scientists to the table earlier to talk about what are going to be the societal impacts if we start bringing in some of these technologies. So that has to happen really, really early. To your question, one other point I was going to raise is that sometimes when we talk about research infrastructure, we forget that we rely on platform technologies to make a lot of the research possible. And especially in a country like Canada, or trying to talk to Volkmar today, we're a very large country, and trying to ensure that we can collaborate across the country. We're learning a lot now about how we can actually do it virtually. I'm sure a year or so ago, right, we would all be in Ottawa having this panel. But we're seeing the problems today, right? We don't have infrastructure yet that we can reliably have really robust conversations and do it in a way that's more participatory. We're still learning and feeling, but there's also technology that has to evolve there. So there's also a need as we do this to figure out how to collaborate people across large distances, both through the internet and communications, but also in the ability to share data across these sites, to have enough bandwidth, to have the places to store it, to have the computing facilities to deal with it. And so I think we also have to focus, when we talk about research infrastructure, on how do we make collaboration better, so that the investments we're making, we can do more if we're able to invest very strategically and allow people to actually collaborate from a distance in those facilities.
That's really interesting. Geneviève, you're located in Quebec, and we've noticed that the Quebec government has been very proactive in supporting the research of Quebecers, both regionally and internationally. And what is the secret sauce that Quebec has that makes the province so anxious to be an international player and a leader?
Well, I think one of the things that Quebec did, and I'm not from the Quebec government, so I'm going on a limb here, but one of the things that happened in Quebec is that we decided to be complementary to what happened in Ontario. So if there was funding for individual researcher in Ottawa, in Quebec, it was for collaboration amongst researchers. And at first, of course, people got together from the same department sort of thing. But with time, they learned that if they get all the strength of all the universities in Quebec to work together towards a single goal, it was even better. And so those walls broke down slowly, but you need to remind everybody about that. And we see this now very well on the Canadian scene, people collaborating together on different types of platforms, such as the ones that Gail mentioned. I can talk about astronomy. And what's interesting about astronomy, bringing it back to the Canadian side, is how the astronomy community writes long-range plans that are the roadmap that Volkmar was talking about. And it's not only the astronomy community from the universities and the colleges, it's also the astronomy community from the industry that comes along and says, this is important for us to develop this knowledge and to be able to look forward to the next instrument that we will build. And so for astronomy, they actually rank each of their projects, and it's very clear what they do. Another example of that is the challenge programs that we have at NRC, which allows us to actually bring together the strength in universities, the strength in NRC and in other government departments, and work on a given subject. And again, we have the high throughput and secure network program, which aligns not only the traditional fiber technology to bring it to the population of Canada from coast to coast to coast, but also thinks about the new ways of doing communications, which involve quantum communications, and looking at ways for satellite communications to be even more productive, particularly with the populations up north, and the population even close to our cities that are not able to get satisfactory bandwidth. So we're working on these problems, and we need, as the other panelists said, definitely not only a link between the foundational science and its application, but also the links also between society and what we're doing, and to make sure that it pays off in the end for what the Canadians are investing in research and innovation.
That's really good. When we talk about sharing, one of the hot topics today is open science. And I was at the Vienna meeting on international infrastructure, and people raised their hands in the audience and said, we should require all in big facilities to require everything that's done to be open. And as I listened to that, my generous heart thought, yes, that's wonderful. But then I started thinking about the companies that want to use the equipment and maybe are very competitive. And then I began thinking a little bit about, rapid publication is really good, but would it be really good for a small country? Gail, do you have an answer, or somebody else?
I'm sure I can jump in with a few thoughts. Clearly, if you're talking about curiosity-based, fully federally funded research, there's a really good argument that it should be open. When you're talking about federally funded together with company funding, you have to start really looking at the public policy and what are you trying to achieve in that government funding for that project, and should that be, how open should that be? I think sometimes we say open science, assuming we all mean the same thing, but open science can mean very different things. It can mean publications that make it clear what the discoveries were that were made, and perhaps not all the data. And from a company perspective, that might be acceptable. It might be harder if you have company proprietary data to make that available, even if you can publish the algorithms or some other work that was done on top of that data. Sometimes when people talk about open science, they mean all of it. They mean the data, they mean the scripts, they mean the analysis techniques, they mean everything. And I think we have to be much more careful about how we think about it from a public policy perspective and carefully define what we mean by open science.
Volkmar, what do you think from Germany?
Yes, thank you. So many things are already said. I think open science is a very good idea, especially in fundamental science, but I completely agree if you have a, let's say, a cooperation with industry or with a company, and a company invests, for example, for an experiment at the large infrastructure, this cannot be published immediately. Usually we have a strategy at the large infrastructures that the data produced by science are these findable, accessible, and reusable, and so on, this FAIR principle, and but can be used by the one who produced the data, who did the measurement exclusively for a certain time, let's say 1 year or so. I don't know exactly the rules. So it's open data, but for 1 year or so, there is exclusive use of this data by the scientists who produce the data, just to give them the chance to do the publications of all their work they have done at the research infrastructure. But then it should be open to all scientists.
That's really good. We got a question on the screen, which leads actually to one that we had on our list. And that is, we are all worried about cybersecurity these days. And between open science and cybersecurity, the stealing of information, so sharing and stealing, where is there a line of conciliation, or are they two separate realities in which between which we must live? I don't know. Fred, do you want to try?
Well, again, this, dealing with sort of the management of security and integrity of data systems clearly is going to be an increasing challenge if we are moving more towards the objective of open science. I think there's a variety of ways that have been thought about to do this. One way is to actually perhaps have what they call security zones in the data, so that you first have certain associated groups that can access the data. There's only certain individuals and groups that could actually alter the data. If you have data systems, if you take a look at global data centers in many areas, whether it's in atmospheric sciences, hydrological sciences, or other areas, there are huge protocols and procedures that are in place for the maintenance of the security of the data, and also who actually can alter the data, and protocols by which that you do that. One of the things about open science is there's a flip side to it. If you don't have appropriate quality assurance, quality control procedures, or people understanding the context of the data, which means there's a lot of metadata that often goes around about what was collected, why, all of those types of things, it could also be taken out of context and actually applied incorrectly. And I think this is where the whole issue of open data and having secured systems of who accesses them, but also how we communicate what's in these data sources in terms of quality assurance, quality control, and other aspects is equally an important piece that needs to be considered. This is not insignificant. I mean, I think it's been raised by Volkmar, Gail, and others, and Geneviève on the call here, that data and the management of data and the direction of that in itself is an emerging science and an emerging discipline in terms of how we go about doing that, all the way from the AI side of things to the security side of things.
So this is a really fantastic discussion that we're having, and I have the feeling that we've just gotten through the surface of it, and we're winding down to the end of our allotted time. But you mentioned, Fred, several times the word communicating, and the importance of correct communication and understanding the meaning of data. But there's also communicating the value of our science and the value of infrastructure, not just to the public, but to the government, and government represents the public. So if I gave you each, a couple minutes to kind of summarize, what would be the message about research infrastructure that you'd want to give to the public and to the government, taking into account what we've said? Who would like to begin? I can see Geneviève has her microphone on.
Was that a mistake? Actually, I think the way to talk to government is to demonstrate that we have the economic, the social, the cultural aspect of Canada in mind when we're talking to the Canadian government, of course. I wouldn't say that to the German government. But I think you have to put things into perspective. Definitely listen to what the government says is important for them, to the message that they're sending to the community. And make sure, as we said earlier, that we all work together. I think we're much stronger together than when we go one by one to try to convince a government official that this is the thing that we need. We need to have a whole community around those, including those that are interested in the results of the research that you will be finding with this platform or with this infrastructure. And that may include some of the citizens that we're talking about, if it's a question of health, if it's a question of the environment. More and more citizens are willing to get involved in these. So, and keep talking to the public. We've seen in this COVID situation, pandemic, that scientists didn't always have the microphone ready to respond to some of the falsehood that were being said, and that does hurt us. And we look like we changed our mind through it all. So communicating science is an art, and sometimes we do need the artists to work with us to help us to frame the message correctly.
Thank you. Gail?
Yeah, I'll jump in a bit. I think CFI has been doing some of this work well. It's about telling those stories that are just really connecting the dots. So I told a brief story at the beginning about research done at UBC with CFI equipment that is now an neutralizing antibody for COVID-19. We can draw a direct line, and we need to tell the story that way. If we try to sell the story just about research infrastructure, sometimes it's not so interesting. But we see lots of stories out there about the CHIME telescope because people are fascinated by what they learn. And we have to connect that to the fact that that's research infrastructure. We have this health stories. We have stories about how social science type experiments have helped us understand whether it's good to learn a second language or not as an infant. So we need to tell these stories and bring up the sentence that says, this was really important that it had a base of funding for a long time and that it was funding for infrastructure as well as people.
Thank you for that. Volkmar? Whoops, you have to turn on your...
Okay, to give, how to reach the public, there are different aspects. Let's say, first aspect is, at least in fundamental science, many people are fascinated by science. We have a lot of activities to reach science. For example, there's every year we have a week highlights of physics, where we reach about 60,000 people. So it's really amazing. But the people are interested. If you talk about astronomy, the universe, where do we come from, where do we go, this is interesting for the people. Or if you talk about accelerators and particles, it's the nearly unimaginable things of technology, what can be realized with these accelerators. This is fascinating for the people. So on the one hand, science does reach the public by this idea of fascination of high-end technology, of the unknown things. But another point is to reach the decision makers, the politicians, for investment. And there are some difficulties. Gail, you just mentioned the COVID pandemic. This is a great challenge. At least maybe some of you have heard in the news that there was found a vaccine by a German company, which is, yeah, we hope it will be successful. The company was called BioNTech, and part of their measurements they did at the synchrotron in Hamburg at DESY. And I've just seen a publication in Cell. This is this journal, a rather famous journal. This is a common publication of the BioNTech people together with the DESY people and also with the people from neutron research. So what we feel is that these facilities, research infrastructures are absolutely necessary to solve these problems, to help with the challenges of COVID on the one hand. But the visibility of this work done at the research infrastructures, let me say, could be better than it is. So there is a problem of communication, and I think this fundamental research is very, very important for the challenges, also for environment, also for if you want to have new solutions for, let's say, renewable energies also. It's absolutely necessary, but it's not too easy to communicate to the decision makers that these facilities are necessary. So this is my point. I don't have a solution to this problem. We try last year, but it's difficult, yeah.
That's all we can do. Let's see, Fred, you didn't get to do the last few words.
Well, I think just building on what others have said, I'm also thinking about sort of infrastructure as we move forward. I think what we've got is very good examples of what perhaps has worked and not worked in the past. But as we move forward, how do we have to think differently about not only the types of infrastructure, but how we design infrastructure to basically meet some of the objectives that we've talked about here. So we're talking about open science. We're talking about engaging the politicians if they understand. Remember, the problem with some of our science investments is it goes through several political cycles. So it's a government of the future that often reaps the benefits of the investment of the past, simply because by the time some of the science matures and is really using the facility, those are out of sync potentially between who's invested and what the outcomes are. But in terms of new infrastructure, I mean, maybe we're beginning to see some of these designs, including in global examples. I was recently fortunate to go to the Crookes Institute in London, where basically what they're doing is, and no one would dispute that world-class science is being done out of that institution, but they've also built the facility in such a way that brings the public and others more into the science domain, in terms of communicating science, actually engaging the communities and groups as part of the science delivery. So again, it's not just outward lecturing to people about what the science means, but you're developing programs and areas, including designs of labs, where people can actually come in and see active science being done. And it's not just mysterious people in lab coats anymore that, we don't know what they do and why, but trying to actually get that interplay between science delivery and using the infrastructure and the design of the facility to help facilitate that type of interaction between program delivery and communication of what they do. So it's something for us to think about in the future of how we actually design our facilities and infrastructure, both on-site and networking in terms of how we achieve that outcome.
So we've had some really excellent ideas today. If I'm trying to sum it up, I think that we all said that people were the key and were very important. It's bringing people into the infrastructure. It's the next generation of researchers that need to be trained. It's the scientists that need to be supported with their research and ideas. The infrastructure is there. And Fred, the other day you said, if you build it, they will come, sort of a quoting of Emerson and the field of dreams. But it's the ability for infrastructure, I think we're seeing it today, to be not only the piece of equipment that allows the experiment to take place, but the platform that sends the information elsewhere, that stores the data, that welcomes the people to the research, and provides an environment where people actually work together. When I visited CERN at noon hour, all the scientists were piled together in this lunchroom. And I thought it's like a collision of atoms, except it's a collision of brains and minds. And great ideas are going to come out of them just having their little sandwich together. So in the CFI, in our description of research facilities, we're talking about creating research environments, and not just simply the word labs, because it is an environment for people and ideas, not just for equipment. I think we also talked about reaching out and sharing with the public and the importance, but also the importance of doing that rationally and reasonably, and using proper guidelines and communicating those guidelines. We talked about the importance of creative basic research as essential for later applied research, but how they actually are interdependent and are all part of a single dialogue and a single discussion. We had at the end a few questions that said, are you going to create an international roadmap for all the infrastructure in the world? And I can tell you that every country is trying to do the roadmap for their own infrastructure. So we're a little bit away from that whole international roadmap. But when I see international scientists coming together, I can see the beginnings of that roadmap coming together. I see them saying, we want to build this facility in Japan. How can you use it? How can it be different from what you're going to build in France or Germany or in Canada? What would be the specific specificities of the infrastructure that would serve different kinds of research and permit different activities? I think it's a very exciting time. I think it's a time when people have seen that scientists do have an important contribution to solving problems of the world. And as you said, Fred, bringing people together to solve problems is probably the very biggest and best justification for what we do in science. So I thank you all. I invite everybody to the International Conference on Research Infrastructure that will be June 3rd to 5th. Not in Ottawa, but from Ottawa, broadcast around the world. Thank you very much. I really appreciate your participation. Thank you.
Thank
Thank
you
you too.
very much, Roseann, and the panelists for this very informative and exciting session. It was great, and it really spurs more and more ideas about how we can do science better together. And our investments that we make in the engagement and the environment that we create with people is so key in this. I would like to note once again, thank you for attending our session. To our audience today, your session number is 458. And this is really important to note, because in the survey that you're going to complete, I promise it only does take 2 minutes, so it's really short. The first question you get asked is, what is your panel session number? So it's 458. Please provide the feedback. We need it. And from CSPC, I would like to thank everybody for attending today, and I would like to thank the Canada Foundation for Innovation and the National Research Council for organizing the session, and all the panelists. Your insights were so important and so valuable. Once again, thank you. Please complete the survey, and everybody stay safe and have a great day. Thank you.
Thank
Thank
you.
you.
Thank you. Take care.
Thank you again.
Thank you.
Thank you.